Hello students, Miss Slyman here. I had someone ask if I could make a video on finding second derivatives along with implicit differentiation. And so I'm going to look at that with this equation here. So if I'm going to find the second derivative, well, first I need to find the first derivative. So I would say that that's with respect to x, the derivative of this term only has x's, so that's 2x. Now this term has y's in it, so I know that's going to be chain rule, and in fact it's a double chain rule because I have the y squared. So I'm going to have 4 times derivative of the inside is dy dx, derivative of something squared is 2 something to the first power, and that's it. So now I've differentiated this term, and lastly my derivative here is going to be 0. Well, I could now just differentiate again, or I could isolate the dy dx and then take my derivative that way. And that's what we've been doing with implicit differentiation, so let's keep doing that. So I'm going to actually divide this off and look at the two methods. So first method, I could isolate dy dx and then differentiate again. So dy dx would be equal to, move this to the other side, I would have negative 2x divide by 8y. And of course that's going to simplify to negative x over 4y. Now I could differentiate again with respect to x. This is going to be quotient rule, so I'm going to have low d high minus high, and there's going to be another negative in there. So minus high. Derivative of this is chain rule, so I'm going to have 4 times dy dx all over the square of what's below. So now if I want the second derivative, I don't want it in terms of the first derivative, so I'm going to go in and I'm going to replace my dy dx with my formula for dy dx. So I'm going to have negative 4y plus 4x times negative x over 4y all over 16y squared. And I don't really like having fractions inside of fractions, so I'm going to multiply through by 4y. That's going to give me negative 16y squared minus 4x squared all over 16 times 4 is 64, y to the third power. So that's one method we could have done. I said the other method would be to just take the derivative of this again. So derivative of 2x is just going to be 2. This is now a product, so I needed to use product rule. So I know that, let me actually rewrite this in simplified form. So I have 2x plus 8y dy dx equals 0. All right, so now if I differentiate again, I'm going to have 2 plus first times derivative of the second plus derivative of the first, well, that's going to be 8 dy dx times the second, which is another dy dx. So notice this is actually the derivative squared, not the second derivative, equals 0. So now if I isolate my second derivative, I'm going to have 8y d squared y dx squared equals negative 2 minus 8 derivative, first derivative squared. So that's going to give me negative 2 minus 8. Now I need the isolated first derivative. Well, we did that over here. Negative x over 4y squared. I'm going to get rid of the 8y. So I'm going to divide the whole thing by 8y. And now if I simplify, well, I'm going to simplify by multiplying through by 16y squared, because that's what my denominator is going to be when I square this term. So 16y squared, that's going to be negative 32y squared. Plus, minus. And it's still a negative because I have a negative here. This is going to square and become positive. all over 32. No. That's going to be 8 times 16, which is 128. Is that right? 16 times 8? Yes. 128 y cubed. And now if I simplify, I'm going to end up with this because everything can be divided by 4. Why did I not end up with that? $16 times 2 is 32. And then... Oh, no, sorry, this does simplify. Because here, I could divide through by 4. I could have simplified this as well. So let's simplify both of them. We know we don't need to simplify. We could have stopped here. We could have stopped here. We do need to get rid of the dy dx. We don't need to simplify, but we could. And if we did, these two things would be equivalent to each other because both of these I could divide out of 4. Both of these I actually could divide out an 8. So in the end, I would get the same thing and I would have my second derivative.